Alright everybody, here's our first asynchronous video, which is going to be a lightning round recap of the motion toys that we talked about. Now the very first thing we need to cover here is why when we see a piece of film we think we see movement when in actuality we're seeing a series of still pictures. There's two schools of thought as to why this works. The first is called persistence of vision, and basically what's happening there is our eye is seeing an image and our brain is hanging on to that image for a fraction of a second longer than it's there. While it's holding on to that, the eye is getting a new image and feeding it into the brain, and the brain overlaps the two. As a result, we see movement when there isn't actually movement there. Now, a simple example of this is blinking. We do it every day, probably hundreds of times, if not thousands, and never think once about it. Except now, while I'm talking about blinking, and then you can't stop blinking.
Don't blink.
But every time we blink, we're relatively unaware of the moment when our eyelid is completely closed and the world goes completely dark. That's because our brain is hanging on to the pre-blink image for a fraction of a second until the new image comes in when our eye opens again. A real simple example that you can do right at home to see persistence of vision in action is to take a coin and spin it. When you do, what you're going to see is heads, and then as the coin turns sideways, this creates a gap for our brain to process. That gap is essential. You have to have a break, otherwise the images will become blurry. Now when the coin turns around and you see tails, your brain will merge those two images together so that you actually see heads and tails at the same time. Now the second school of thought has to do with the fact that film is presented through the medium of light, and this uses something called positive afterimage. Positive afterimage is an image basically being burned into our eyes for a fraction of a second longer than it's there. A simple example of this is if you've ever changed a light bulb in a lamp, and when the light bulb turns on, you look away and you blink, but you can still see the outline of the bulb. Another example is on the 4th of July, waving around sparklers, and you create sort of a light trail as you move that bright light source around. That would be positive afterimage, with that image delaying its decay from your eyes to create the illusion of a movement trail. So what's going to happen is people are going to take this concept of persistence of vision and turn it into various toys and novelty items that can essentially monetize the concept of persistence of vision. And that's really what the movie industry does today.
Show me the money!
The first thing we want to talk about is the thaumatrope. The thaumatrope was developed in 1825 by Dr. John Ayrton. It's basically a disc with strings coming out each side. Each side of the disc has an image, and when you pull the strings, the disc spins and the two images become one, just like the spinning coin. Next up is the phenakistoscope. The phenakistoscope was developed in 1832 by a Frenchman named Plateau. This consists of a disc on a stick. On one side of the disc are images. There are slots cut out of the disc, and when you look through those slots while holding this item up to a mirror and spin it, the images in the reflection appear to move. Now, a German by the name of Stampfer created almost the exact same device in 1832, but he called it the stroboscope. Since we're not sure which one came up with it, we're going to give them both credit. Just remember that the first letters of their names start with the same letters as their inventions: Stampfer and the stroboscope, Plateau and the phenakistoscope. Then comes the zoetrope. The zoetrope is basically like a lampshade. Around the inside perimeter are images. There's slots coming out around the outside, and then when you spin this and look through the slots into the middle, the images appear to move. If you've ever been to the Henry Dorley Zoo, they have two of these at one end of the gorilla complex. One is of Darwin's evolution of monkey to man. The other is an orangutan swinging arm over arm through the trees. Now, taking this concept one step further, Pixar created a 3D zoetrope by following an example set up by Studio Ghibli. Take a look.
Instead of drawings, we're using sculptures. So what you're seeing are 18 different sculptures, each slightly different than the last one. And instead of flipping through them, we're using a strobe light to make those images stick in your eye. And these spinning images freeze in space, and each sculpture replaces the last one and appears to move. It's stunning because it looks like it's come to life right in front of you.
Now we need to jump quickly out of order in history here to pick up one invention that's been around for a lot longer but is going to be needed for this next step, and that's called the magic lantern. Now the magic lantern in essence is the ancestor of the modern day projector. In short, you have a light source, you have a lens, and between the two you put an image that is then projected up onto a wall. That brings us to Franz von Yucanius, who's going to work between 1845 and 1853 to develop the first projected moving images. Now he's going to do this by basically taking a magic lantern and putting images in a sequence so that as he pulls them through, they're projected up on the wall one after another to create the illusion of movement. Eventually he's going to figure out, wait, if I put these on a phenakistoscope and stick that between the light source and the lens, then I don't have to pull this really long strip over and over and over again.
that'll only make someone work just hard enough not to get fired.
This creates the first, albeit very crude, projected moving image, basically the ancestor of the modern day cartoon.
Neat.
Next up is the praxinoscope. The praxinoscope was created in 1877 by a guy named Raynaud, and it was very similar to the zoetrope, except instead of slots cut through the side, there's mirrors set in the middle. Because the mirrors are set edge to edge, the point where the mirrors meet is what creates the gap for our eye so that our brain has time to process the image. When you spin it up and look at the mirrors, you see the illusion of movement. The one thing all of these motion toys had in common was that the images were hand-drawn. From here, we need to sidestep to pick up the history of photography to put the two together and create the first films.